Hello, I'd like to thank you for joining us today. We're going to talk about a project I've been working on a bit with the Kolla-Ansible distribution and why I think that OpenStack containers and Netapp makes one of the greatest private clouds you can run. I'm David Blackwell. I'm the technical marketing engineer, which means 1/3 of what I say is garbage. But I'm the technical marketing engineer for OpenStack and configuration management for Netapp. And one of my responsibilities is to find ways to accelerate the field's use cases around OpenStack. And I've decided, and you can agree with me or not, that containerizing OpenStack is the greatest advancement there's been in OpenStack since ever, since the inception of OpenStack. Why would you want to containerize OpenStack? What's the reasonings? So let's get out of the way with some of the obvious. Deployment of OpenStack is difficult. Even if you're going to use Fuel or Director, OOO, et cetera, you have the risk of one misconfiguration in your Pixie server can bring an entire network segment down. If you are just doing test cases, you have to figure out how you're going to set up your servers and what you're going to use until you're ready to pay for a licensing or run something else. No one will try to tell you with a straight face, unless they're a sales guy, that OpenStack is 100% easy to deploy. Additionally, you have to plan how you're going to do upgrades from day one. Most application processes, upgrades are built into them. With OpenStack, you have to decide, this is how I'm deploying. Will I be able to upgrade via this deployment method? I myself found this out the most difficult way as I was writing software to allow our field salespeople to set up proof of concept systems with basically a wrapper for Packstack, that when they set these up at people's sites and a new release came out, there was no mechanism within that to do the upgrade. Because I, myself, didn't think at day one, how will I upgrade this in 6 months? Automation for configuring the system really has to be set up by the administrators. Now, again, Red Hat OSP and Fuel have a lot of setups in it to help automate some of this, but still parts of it are required by the administrator to determine how that's going to be done. Also, if anyone's ever had a failure during an upgrade of OpenStack, it's next to impossible to roll back to a consistent usable state. You're almost required to rebuild. By switching to containers, it simplifies deployment. There's already images for Kolla, for example. They're RDO images, but there's already images that have been created that have all the drivers, all the libraries, all the binaries already in place for what's going to work. And the images, because they're containers, while your configuration setup might not be right the first time, the containers are guaranteed to work. It simplifies ongoing operational choices because you have that ability to do upgrades at an individual microservice level as well as at an entire release level just by downloading the new images for the new release or for a patched image set and running, in Kolla-Ansible's case, there's an upgrade playbook role that will actually step through your services without interrupting customer use case and stop the old container and start the new one. And because they're microservices and because it's Docker on bare metal, it's all but instantaneous on a per service level. I've done upgrades from Pike to Queens on a multi-node deployment without my instances going down in 5 minutes. So that's really, really cool. It improves your DevOps workflow. Let's say that as part of your DevOps workflow, you need a tiny OpenStack environment. You need an entire environment to test something against. Well, especially in the olden days, even if you're using Fuel or Director, that means you need an undercloud. You need your nodes for your overclouds, even if they're Even if they're virtualized, you still have to have all that set up. You still need your Pixie configurations right. And an all-in-one system generally isn't as useful for testing actual application or service projects. So being able to have a simplified playbook deployment based on pre-configured configurations really makes that a much simpler process that you can run over and over and over. And because it's Ansible-based and really well done as Ansible-based, it's repeatable, reliable, and fast. And what I mean by that is, because it's Ansible, you can deploy and then run deploy again if you so desired, and it wouldn't affect your current environment. Try doing a pack stack install or something and then doing it again on the same system and not have issues. It's fast because all it's really doing is copying configuration files to your nodes, setting up containers and having read-only access to those configuration files linked into the containers. And it's reliable. Because it's Docker, because it's containers, if you have it work correctly once, it will work correctly every time because it's just repeating the same steps. I've tried a lot of the different containerization settings. Kolla-Ansible, Kubernetes, I tried OpenStack Helm. And while I see a lot of advantages to OpenStack on Kubernetes, I personally had too much difficulty getting the kernel pass-throughs for iSCSI and NFS to my service containers, which made it difficult to add Netapp's storage as a service automatically. And because I work for Netapp, that's what I want to do. I actually asked the Kolla-Ansible people directly about how to fix some of this. I'm sorry, not the Kolla-Ansible people, the OpenStack Helm team directly how to fix some of this. And both teams have really excellent people. So if you start working with either of these on IRC, they're very friendly and forthcoming. I told them I wasn't going to work with Ceph. I was trying to make another vendor work. And they told me, well, Ceph is used in 40% of all OpenStack. Why would you avoid Ceph? And I told them I work for Netapp. And they told me that's an excellent reason to avoid Ceph. So what Kolla-Ansible actually is, it deploys OpenStack services and infrastructure components in Docker containers. So your individual nodes are still bare metal. Within their inventory file, because they'll have two files that you'll modify yourself, a globals.yaml and an inventory file, you define which hosts have which roles. So there's the top level roles of controller, compute, storage, network, and then there's a couple others, and then they duplicate out for all the different services that are offered by OpenStack. But that's how it knows which microservices and which containers to put in what location. So if you set up an HA, you'll set your 3, 4, 5, however many controllers you happen to want to set up. Now, without your own load balancer, it goes in an active-passive configuration, so more than 3 is overkill. But you'll set your 3 controllers. You'll set all the nodes you want to be compute. You'll set the nodes that you want to be storage, which could also be your controller, however you want it, and then it knows where to actually deploy these containers to. And because it's Docker, there's no dependency issues between containers. I've often done manual OpenStack setups when I first started learning OpenStack. I would download everything myself. I would put everything in the right location. I would do all the individual commands to create things myself. And the problem with that is if you then wanted to try something else, so I've set this up, but now I really wish I had put Magnum in here and I wanted to try Magnum. Now adding that, well, maybe I didn't have quite the right version of something else and now they don't work together. Because when you do it this way, Magnum is its own containers, nothing it does can conflict with anything else. And that's a major advantage of the containerized OpenStack version. And Kolla, I like, uses microservices concept. So what that means, because this is something that doesn't often make sense. So there is a Cinder image. But when you deploy Cinder, you're not deploying one container. You're deploying a Cinder API container, a Cinder scheduler container, and a Cinder volume container for every backend that you wind up configuring. One of the things this does that's so useful is it makes debugging, troubleshooting much better. Let's say you're like me and you're trying to write some PRs to send back to Kolla for your own systems, and something isn't working. Well, I know that I'm only working with Cinder volume. I've not broken Cinder API. I've not broken Cinder schedule. I only have one location where I need to check what it's doing to figure out what I did wrong and go forward. To not have to troubleshoot the entire OpenStack stack is an amazing advantage. And it's Ansible driven. So you're able to run your deployment setting multiple times. Why would you maybe want to do this? Well, my previous example of Magnum. So I have my deployment out there. Everything's the way I want it. But I say to myself, you know, I wish I had put Magnum in this when I deployed it. Well, I can go into my global YAML file for Kolla-Ansible, and I can now say deploy Magnum, yes. Deploy Magnum Horizon, yes. And I can just rerun my deployment. It'll go out, it'll see, oh, I've already created the database for Keystone and my RabbitMQ. I don't need to duplicate those. I don't need to touch them. They're fine. Oh, I already have compute systems going. And there's already containers on these systems. I don't have to re-register them with the system. Oh, it's time to deploy Magnum. So I'm going to now put the Magnum configuration containers out where they need to be. So that's an excellent thing and another advantage to doing OpenStack this way. And again, like I just said, quick OpenStack service deployment. So again, with that Magnum, or even with your entire system, I download all the container images ahead of time before I'm going to do a deployment. And then in my lab environment, that's a couple controllers and a couple compute systems, I deploy in 7.5 minutes. That's how long it takes me to go on my bare metal systems from having no OpenStack running to my full across-the-way OpenStack running. And I dare you to get that fast with anyone else's setup system. And then maintenance and upgrades. If there's a major patch to OpenStack right now, the Kolla-Ansible team has their own maintenance cycles around their images, but they also allow you to build your own. So if you have a specific patch you want, you can build and maintain your own images within your own repository and push those out. And then again, upgrades are just having the newer container images and replacing the existing ones. Now, some people get worried about things like this. What services are supported? I want to do more than Nova, Cinder, Swift, Neutron, et cetera. What services today are supported by Kolla-Ansible? So I don't want you to read this list, but it's more than 4. So there actually is a great coverage of modules. Some of them don't have the same depth of configuration options out of the box, but because everything's Ansible-based, it's incredibly easy to add the extra options you want into the roles for these services, as I wound up doing for Netapp. Now, I really wanted to add Netapp to the mix for this. And it turns out that our customer 0, if you were in one of my earlier sessions, is going to be deploying our level 3 OpenStack environment via Kolla-Ansible. But they were going to go in manually and add the Netapp functions after the fact. So they're excited when they found out I was actually doing work on this. But why do I think Netapp is part of that trifecta of what makes the best private cloud? So we have advanced storage options for OpenStack. Not only are we a major consumer of OpenStack and a major contributor of OpenStack, past PTLs for Cinder and Manila work at Netapp. We've contributed more code to Manila than any other group. And we're a major contributor to the Cinder code frame. And because of that, we're able to get a lot of the features that we like to use, which I'm going to go over in a future slide, in to make your use cases with OpenStack better, faster, and cheaper on Netapp. So while you do have to pay for Netapp, there's cost savings in storage usage. Like I said, we're a major contributor to the Cinder code-based, and we've contributed over half of the Manila code-based. 5 out of 7 enterprise OpenStack installations use Netapp in some form or fashion. Maybe they're testing it with SolidFire. Maybe they have ONTAP on the side. Maybe they use it in a very ineffective way as external storage into their instances. But what we've gotten back from the OpenStack Summit surveys and information surveys we've done on our own is that we are in 5 out of 7 enterprise level OpenStack installations. What are the major advantages? Because this is really where I feel it shows why we're part of what I call the trifecta for OpenStack. So from Cinder, snapshots are file clones. What do I mean by this? Well, let's take the #1 used storage backend for OpenStack, Ceph. If you take Cinder snapshots in Ceph, that is a full copy of that Cinder volume. So now if this was a normal file system, you'd have your original Cinder volume and you'd have a copy of it. So you're now using twice the storage. But this is Ceph, so you're probably going to have a minimum of 3 replicas. So you're actually using 3 times the storage for the original and 3 times the storage for the copy. So not only with Netapp is the original only a single replicant because of our underlying RAID structures, the snapshots are what we call flex clones. A flex clone is a block level pointer to the original files. So when you take from the Cinder command line, from the Horizon GUI, from the OpenStack CLI, when you take a Cinder snapshot using the Netapp drivers and an ONTAP backend or a SolidFire backend, it takes advantage of our system drivers and creates this flex clone. So you could sit down and create 1,000 snapshots of a volume, and until any blocks change in that original volume, you'd use about a mega space, because each snapshot is 4K, because that's how much it takes to make a block pointer to the original file. You can also do the same thing with active volumes. So let's say a user says, you know what, I'm using project volume A, and now I have to set up an instance for all of my developers to have their own individual instance, and they all need a copy of this volume. Well, you can do the same way. You can clone the Cinder volumes, and when you use a Cinder volume clone with Netapp, it does, again, a file clone. So it creates 0 space, just that 4K copies for them that they can then access and use without any extra space being used over that. Additionally, so 1,000 can be taken. Additionally, we all know, anyone who's an admin or an operator knows end users are terrible about backing up their storage. They don't do their own backups, they don't control it, but then whose fault is it when they delete or ruin something? It's my fault. Of course it was my fault. I didn't hold their hand and make them click a button. I just gave them the tools. Well, with Netapp as a backend, you can set up volume level snapshots, and I'm talking about the Netapp volume, not a Cinder volume, to still have daily or weekly or hourly rolling backups that can do up to 254 snapshot copies, which again are only 4K even at that sub-level. So you can have full Cinder backend restore or the individual Cinder volume restore. Something else that makes this an advantage is our snap mirror technology, or based on these snapshots. So your first baseline is going to be everything that has to be moved, but every update is just the blocks that have changed from the last time you did a snap mirror to this time. And you can run ONTAP in AWS, in Azure. You can run ONTAP Select on KVM. So you can actually be snap mirroring out your Cinder volumes. And while we all know, anyone who's had to administrate OpenStack for a long time, it's difficult to import those volumes into a new OpenStack system. It's not hard to just have access to them. And by snap mirroring them out, you can then mount them read-only as a loop device and still have access in a disaster recovery environment or an individual file restore within a Cinder environment, access to the files because of the way Netapp does its underlying storage. Deduplication. A lot of people do deduplication. I think we do it best, and not just because there's a giant N on my paychecks. But what deduplication will allow you to do is it's any blocks that exist more than once, it deletes all the extra ones and just puts in pointers again. So you have glance. You have to deploy 100 instances based on this glance golden image. Now, in any place else, that is 100 times space you're using for all of those systems. With ONTAP and deduplication, that is, after deduplication, that's about 1.1 times space, because all of those images start out as the same, so they don't all have to exist. And with an all-flash FAS system, that dedupe and compression is in line. So it actually happens as it's creating those files. Additionally, I'll have questions at the end. Additionally, Glance images that aren't yet cached on the Cinder side, we have a copy offload utility. So as long as you're using an NFS share from Netapp for your glance location as well, you can actually offload the process of copying that image into Cinder from your OpenStack side to the Netapp backend side. NVE, this is something we have added since our 9 system release. And in 9.3, you can actually convert non-NVE to NVE. This is Netapp Volume Encryption. Data protection is on everyone's mind. This allows a dead simple set and forget volume level, and again, that's Netapp volume level, not Cinder volume level, encryption at rest. So you can turn this on and know that everything's encrypted. If those disks somehow get taken from your system, even if they take every single disk, they will not be able to put it in any other system and recover any of that data. And you can do a full QoS catalog support. This is actually where SolidFire shines the most. You can set up your Cinder backend types and give them IOPS range, min, max, burst, and change them on the fly. So if you deploy a database and they tell you, hey, we're going to be an easy load, we only need 4,000 IOPS, you can deploy them in your Silver or whatever you set your IOPS group to. And then they find out we actually do a lot more than we thought we did. We need quite a bit more IOPS. You don't have to destroy and recreate their volume. You don't have to unmount it and remount it. You can just, all from OpenStack, change the volume type that you've defined for it to the higher QoS level, and it will automatically make the changes on the SolidFire backend, boosting their allowed IOPS integration. For Manila, Manila is also fantastic. We have full ONTAP snapshot support. Those same snapshots I mentioned for Cinder, since Manila creates a volume for each share that it's doing, the Manila snapshots are actually volume level ONTAP snapshots. One of the biggest things this gives you, and if you come by our Netapp booth, I can show you a demo of DevOps using these snapshots. So what I mean by this is, if you're a developer and you're working on some software, you make a snapshot before you want to make a major change. That major change broke everything. And I didn't remember to do a git commit or a git pull, and now I've ruined my software. But since I did the snapshot through Manila, I can do a Manila restore of that snapshot. I don't have to unmount and remount my NFS export or my CIF share. As soon as I do that restore, the data is back the way it was when I did that snapshot, allowing real-time, fast conversion between the current file system and one that you snapshotted in the past. Replication is built into Manila, and using ONTAP as a backend, you can set up replication via multiple availability zones, and it uses our SnapMirror technology in the backend, allowing for far better control over how much extra bandwidth is being used and a lower total bandwidth usage. Non-disruptive migrations. This is my favorite demo to do. I create a NFS share using Manila, and then I set that NFS share as my Cinder backend. I create an instance that has its root disk on that Cinder backend, and I start a DD operation, so if there's constant I/O on that. And then I issue my Manila migration command, moving it in my ONTAP cluster from one cluster node to another cluster node and across multiple aggregate RAID sets. And I'm able to show in the demo that it moves this entire share from not only from disk to disk, but from physical node to physical node, and the instance is never interrupted. My SSH doesn't time out. The uptime count never stops. The DD's never interrupted. So that's an incredibly advantageous feature that Netapp allows with Manila. And then again, NVE. NVE can be set always on for Manila, or you can set different types. Maybe you have some groups that for some reason are angry about your at-rest encryption. I don't know who these groups are, but they could exist. So you can actually define different keys for your types and have some Manila shares that are automatically created with encryption and some that aren't. Now the changes I did for Kolla-Ansible aren't even all that extensive. This is another one of the great things about Kolla-Ansible. For the globals file, I had to add 2 new backend definition types. Do I want to enable my Cinder backend for ONTAP NFS? Yes. Do I want to enable a Manila backend ONTAP? Yes. And then 2 locations further down the file where you can fill in the information that would be unique to your environment. That would be the Cinder export path you want to use. That would be the host name of the ONTAP system you're going to use and your login information. For Cinder to actually work as part of the deployment, I had to make very few changes. But in the defaults main YAML from the Cinder role, I added the ability that backend can be enabled and defined because these things create your config file. I added a task config to use the NFS shares file that was created to read that share path that was down here at the bottom, ONTAP NFS exports path, to be able to create that extra file. And then pre-checks, there's a pre-checks role you can run for Kolla-Ansible. I put in a pre-check that if ONTAP is defined, it no longer complains that there's no backend for Cinder. And then updates to the Cinder config template file. Sorry, my brain stopped for a second there, in order to use all those variables and build that conf file. Manila actually only needed 2 changes. Just the main to add the driver definition for ONTAP, and then a share conf information for that particular Manila share. Now, I could stand up here and talk all day about how we did this and how fabulous it was, but I always like to see some level of proof. Now, these are pre-recorded because live demos in situations like these never work right. So accept that they're pre-recorded, but what you see is what you get. Other than speeding them up a bit, I made no changes. If you've never gotten to use Kolla-Ansible, this is literally all there is after you've made your particular configuration changes to the global file, and you know that your hosts have Docker and whatnot pre-installed, which there's also a Kolla-Ansible bootstrap you can run to push that yourself. That one line starts your deployment. And again, while I've sped this video up to be 3 minutes, which is still, I think, a little long, it only took 7 minutes to do this deployment of a multi-node ONTAP deployment. And what's scrolling past really quick, and some of the things it does that makes this so great, is it's creating in a Etsy Kolla directory on the different bare metal nodes, files to put in config files for every microservice that runs. So there's a Cinder-scheduler that has the API configurations and a Cinder.conf and a Cinder-volume and everything else that's needed to make OpenStack fully work. It's creating the database and setting them in. It's using the passwords that are in a password file that I generated before this, but also means that I can just keep everything that I have as a configuration and deploy the same thing into any environment. What I also haven't pointed out, because this is just how I choose to manage it, is this is actually running from a container. I'm not actually running the install on any of the nodes that I'm using for OpenStack. That way I can take that container and I can either take the configuration files and send them to Git, which is what I do. So when I have a new deployment I want to do or a new test, I pull down my pre-configured globals and inventory file. Or, and I've also done this, I can just package up that container and share it with someone, and they can do their same deployment. So you don't even need the management system you're using to be part of that OpenStack environment. And that's one of the greatest things. And as the containers come up, they get read-only links to your config files. So even if some horrible thing goes wrong and your containers run amok, they can't damage or destroy or even alter your configuration files. However, you can, if you have a test you want to do, you can manually change your configuration files and restart the container, and they'll read in those new changes on restart. Now, just to show this is the same system after the deployment. Whoops, nope, yep. Same system after the deployment. I wound up skipping where I show you the services list. But there we go. Just to show you my Netapp backends. So if I run my Cinder Git pools, there's the NFS share that I was using that you saw in my globals example. And I want to do a volume create because it's all fine and good to be able to show you a backend shows up, but if there's errors, it won't actually work. So here I've created a volume, and then I'm going to list that volume just to show you there's no error. It's actually created. It's an ONTAP volume type. And then for Manila, oh, sorry, I forgot. I'm also showing you the details so that you can see that, yes, I did indeed use an ONTAP volume type, which is on my NFS share for the host connection for the backend. And then for Manila, I create a default type without it managing the share servers. That's just my personal preference because it's easier. I can create the share type, create a share using that share type. And this creates a volume on my backend on the Netapp system. And then I can list it and see, you can see my share in my environment. You can see the aggregate I've put it on, the node it's on. And from here, I'm not doing it in this demo because I've shown now that it works, but your access lists, your export allowances can be manipulated here, and they're created then on the backend Netapp side. I also want to point out that we have more sessions this week, several tomorrow, and we hope you stop by our booth if you have any questions. I have some demos on some of the stuff that Manila does. I have a demo on that automatic QoS, or that catalogable QoS solid fire backend. I'd be happy to show anyone who wants to see them. And I thank you for your time. Do we have any questions? And if you do, could you come to the mics to ask them? Okay, so I either did really good or really bad based on the fact that no one has any questions. Excellent. We do have a raffle now. The real reason I know you all listen to me. I appreciate the faking, but anyone not get a blue ticket? Yep, so the raffle's for a bamboo folio. It's made by Wacom. Whatever you write on it, it transmits it to your phone.
I have a question.
Yeah.
How many Cinder volume containers do you spin up like at any given point?
How many Cinder volume containers? Oh, so a standard deployment is 4. API, scheduler, I'm trying to remember what the next one is, manage, I think, and then 1 per volume backend, generally. And for my example testing, I only configure 1 Cinder volume backend. But if you configured multiple, each one would get its own Cinder container. So it'll also separate troubleshooting at that level as well.
And you spin up on a different machine, different nodes, right?
Yeah, it'll spin up on whatever node you define in your inventory as the storage nodes. So in my example, it spins up on my controller nodes. That's where those containers exist. But I could have defined a standalone storage node to handle all the bandwidth that Cinder would have to then hand out to Nova and et cetera.
Sorry, when you do the snapshots in the OpenStack, will it just trigger the snapshot in the ONAP? Or?
So he's asking about snapshots in OpenStack and if they trigger snapshots in ONTAP. For Cinder, it triggers that Flex file clone to make those zero-space backup snapshots. So they're not Netapp volume snapshots. They're technically Cinder snapshots, but they're done instead of a full copy. They're done as clones. In Manila, yes, it does trigger the back-end Netapp snapshot technology to create a volume-level snapshot.
So the way you did that is by modifying the Kolla-YAML file for the Manila.
Yes, I added the ability to use Netapp as a backend for Manila and Netapp as a backend for Cinder. The ability to do those options as the Flex clones or as the actual snapshot has nothing to do with Kolla-Ansible. Those are actually written into the ONTAP drivers for Cinder and Manila. Those are just part of the OpenStack project. You can download them. You can look at the source code and how we do that. It's all there. I work for the only group in Netapp that gives everything away. So there's a Netapp driver for Cinder, for iSCSI, and for NFS. There's a SolidFire driver for Cinder, which is an iSCSI connection. And there's even an E-Series, which we don't talk about all that much, driver for Cinder for using our E-Series systems. And for Manila, there is a ONTAP backend driver. It doesn't specify protocol because you create CIFS or NFS as you're using it. Yep.
Maintenance-wise, how do you manage your snapshot? Do you delete the old one manually?
So with snapshots, if they're Cinder snapshots, you delete them manually. If they're Manila snapshots taken from OpenStack, you delete them manually. If they're scheduled snapshots that you've done to protect your end users who don't think to do snapshots themselves, you can actually set the system to only keep X number. So maybe you want 1 an hour for 6 hours and 2 a day for 3 days. So it'll keep 6, and when it's done 6 hourlies, it'll delete the oldest one and add a new one. And when it's done 2 a day for 3 days, it'll delete the first day and do new ones. There's also the option for space reclaim, because volume level snapshots, depending on how much delta you have, can grow very large. And you can actually configure ONTAP to delete them as needed, the oldest one up, in order to free space.
One more question. Kolla-Ansible is the same thing as the Red Hat Ansible?
So Ansible is Ansible. It's made by Red Hat. Kolla is an OpenStack project for deploying containerized OpenStack. They have a Kolla Helm and a Kolla-Ansible project. Helm is for deploying on Kubernetes, and Ansible is for deploying on bare metal as Docker. Red Hat doesn't write the Kolla-Ansible playbooks.